Hello students, my name is Dr. Gajendra Purohit. I upload videos for engineering mathematics B.Sc on our YouTube channel. And if you are preparing for any competitive exam where higher mathematics is asked, our YouTube channel can be very helpful. I have explained previously what is Fourier transform, Fourier sine transform and Fourier cosine transform. How do we solve partial differential equations? Through Fourier transform. I have already uploaded all these videos. You can watch them. Today I am going to explain to you the discrete Fourier transform. And I will also explain what is its concept, how do we take the discrete Fourier transform and the inverse discrete Fourier transform of any sequence. So let's get started. If we have any sequence given, see discrete means that when we don't have any continuous function, suppose we have any sequence given here and we have to find its Fourier transform, right? But usually we take the Fourier transform of a function. We study Fourier transform of a function, but if we don't have in that form and it is given in sequence form and we have to find its Fourier transform. So how do we find it? If any real sequence is given and we find its Fourier transform, then that gets converted into a complex form. And when any complex sequence is given, we find its inverse. Then we get real sequence. This is also given here that the discrete Fourier transform converts a finite sequence of equally spaced samples into the same length sequence of equally spaced samples, which is a complex valued function of frequency. I will explain you about it. First, let's discuss about the definition. The discrete Fourier transform, a sequence of n numbers. This is a type of sequence that will be given and you will be asked to find its discrete Fourier transform. What we will do? We will apply a formula to it and I will explain the formula later. When we will apply it, then what will happen? This sequence will be converted to a complex sequence. Now you will ask what is the formula. So if we have any sequence given like this, how do we find Fourier transform, the discrete Fourier transform of the sequence? We will write x in capital letters here. Xk is equal to the summation of n is 0 and then n minus 1. And in this we will write small xn. And then here omega raised to the power n. Okay. We will get this value here where the value of omega is e raised to the power of 2 pi multiplied by I upon capital N. Is it clear? This means it is the nth root of unity. I will explain about it. This is a sequence xn given and we find the discrete Fourier transform of this sequence. So we get this type of sequence formed in x. I mean we get sequence in form of capital X. This is known as a complex sequence. Is it clear? Now suppose it is asked that if we have a complex sequence, which means a sequence of this type, and we are asked to find the inverse discrete Fourier transform, what we will do, pay attention, this xn will come out. This will come out, here it will be the inverse discrete Fourier transform, right? This is the discrete Fourier transform, clear? Note that this xn will come out. This capital X here will go inside. Students, you need to pay attention here once. We get this as 1 upon n here, right? It will be 1 upon n. It is summation k is equal to 0 to n minus 1. This will be capital Xk and here it will become omega to the power minus nk. Clear? So this is what we have as the inverse discrete Fourier transform formula. And this is what we have as the discrete Fourier transform formula. What we will get as the value of omega. Its value is 1 upon nth root of unity. Now I will try to explain through one example. Look here, we have a question given, find the discrete Fourier transform of this sequence, right? It is 1, 2, 3, 4. This means this n here, what is the value of this capital N given? 4. What we have to do? We have to find the value of capital Xk. We will get summation of small n is equal to 0 capital N minus 1 and this will be small xn. And here it will be omega raised to the power nk. Clear? And here what is the value of omega? The value of omega here is e raised to the power 2 pi I upon capital N. Value of capital N is 4. This means that its value upon solving here will be pi I by 2. If I write this, it will be cos pi by 2 plus iota sine pi by 2. We know its value is 0 and its value is 1. So from here, what will be the value? It will be iota, right? We will put this iota here, right? What will be the value that we will get here? It will be pi. Capital Xk will be equal to the summation. Here it will be n is equal to 0 to capital N minus 1 and this will be xn. And here it will be iota raised to the power nk. Now it is given 1, 2, 3, 4 in the question. We will find a complex sequence corresponding to that. First, what we will do is substitute the value of k as 0. When we will put 0, then we will get x as 0. And note that here the value of small x 0 is 1. The value of small x1 is 2. the value of x2 is 3. And note that value of small x3 here is 4. Is it clear? Keep this in mind. Corresponding to it, we will find capital X0, capital X1, capital X2 and capital X3, which will be its discrete Fourier transform. So x0 is equal to, what do we have here? Wherever it is k, we put 0 there. N is equal to 0. The value of capital N is 4. So this is 4 minus 1, that is 3. And xn as it is, and we will put k as 0. It will be iota to the power 0. This will become 1, clear? I will expand this and put n as 0. So x will become 0 plus. Then it will be x1 and here x2, then it will be x3. All these values are given. We will just substitute. On putting these values, we will get 1 plus 2 plus 3 plus 4. So 4 plus 3 is 7 plus 2 plus 1. The value will be 10. So this is what we will get here as its value. Now students, if you are asked, what will be the value of capital X1? You need to put k as 1. When the value of k is put as 1, then this will be n is equal to 0 to 3. Wherever it is k, we will put 1, then you will get xn into iota to the power. Here it will be n because we are placing the value of k as 1. So it will be iota to the power n. When we will put n as 0, x will be 0, iota power 0 will be 1. If we will put x1, it will be iota to the power 1. If we will put x2, then it will be iota square and x3 will be iota cube. We will put the value of x0 as 1. Then x1 iota, x1 is 2. This will be 2 iota. The value of iota square is minus 1 and value of x2 is 3. This will become minus 3. And pay attention to iota cube. Iota cube is iota square into iota. The value of iota square is minus 1. So this becomes minus iota. Minus iota into x3 will be minus 4 iota. If we will simplify this, we will get a value of minus 2 and minus 2 iota from here. So we will get the value of x1 from here. Now we will talk about finding the value of x2. What we should put here as value of k? We should put 2. If we put the value of k as 2, then n is equal to 0. 2, 3, xn. What will come here? We will get iota to the power 2n, clear? We can also do square of iota here and we will get minus 1 power n. We can do this too, but let's expand it. This is better. We will put n as 0. So x will be 0, small x 0. Then we will put 1. So students, we will get this as x1 and then iota square here. Then this will be x2 and iota to the power 4. So students, here we will get x3 iota to the power 6. Now we will put its value. And the value of x0 is 1, right? Iota square is minus 1 and x1 is 2. So this will be minus 2. As value of iota power 4 is 1 and value of x2 is 3. So this becomes 3. And iota to the power 6 can be written as iota to the power 4 into iota square. Its value is 1 and this is minus 1. So this will become minus 4 here. Clear? 4 plus 2 is 6. 4 subtracted from minus 6 will be minus 2. Clear? So students, what will we get here? We will get x2. In the same way, we will calculate the value of x3 here. What will we put as the value of k for x3? We will put it as 3. When we will put 3, it will be summation. N is equal to 0 to 3 and xn. This will be iota to the power. It will be 3n. Now students, put the value here. This will be x0. And we know that the value of iota raised to the power 0 is 1 only. Plus this will be x1 iota cube. Plus this will be x2 iota to the power 6, right? And here it will be plus x3 iota to the power 9. Do you understand? We will put 1, 2, 3. The value of x0, right? Let me write it here. What is the value of x0 that we are getting here? It is 1. Now pay attention. The value of iota cube is minus iota and the value of x1 is 2. This will be minus 2 iota. I just explained iota power 6 is iota power 4 into iota square. It is 1 and it is minus 1 respectively. We are getting x2 as 3. So this will be minus 3. We can write iota to the power 9 as iota power 4 and iota. Iota to the power 4 is 1. This will be iota. So we get iota. Here value of x3 is 4. So we will get its value as 4 iota. When we will simplify this, it will be minus 2 plus 2 iota, right? We will get this as its value. And its sequence here, the discrete Fourier transform of this sequence, which we will get, I'm writing it here. Whatever we will get as the Fourier transform, the value of its sequence. First on solving, we got capital X, which is x0 as 10 here, and after that, from here on solving, we got the value of this as minus 2, that is minus 2 iota. Then if we see next value that we are getting here on solving, it is minus 2, and after that, we got the value as minus 2 plus 2 iota here, right? So we got the discrete Fourier transform of this sequence. And what is this value here? It is the answer. Now, the next question which we will solve, let me tell you that we will get that as its inverse discrete Fourier transform, right? That means I will show you calculation of its inverse here. So we will get 1, 2, 3, 4 values here. Let's proceed. Now let's discuss about inverse discrete Fourier transform. I had told you at the beginning of the formula, if we have xk sequence, how do we find its inverse discrete Fourier transform? We will get a complex number. When we will take its inverse, we will get a real sequence. Its formula is xn equals 1 upon n. Summation k is equal to 0 to n minus 1 xk, omega to the power minus nk, where the omega is nth root of unity. I just explained you this question. Now I will tell you about the inverse discrete Fourier transform. How do we calculate it? Here, first of all, let's talk about omega because the value of capital N. Again, it is 4. So, the value of omega will be, it will be 2 pi I upon capital N. It will be e to the power 2 pi I upon 4. It will be e to the power pi I upon 2 and this will be cos pi by 2 plus iota sin pi by 2. We know cos pi by 2 becomes 0. Its value will be iota here. It means what is the value of omega? The value of omega is iota. If it is given equal to the x, as you can see, it is given equal to the capital X here, right? Now we need to find the value of small xn. We need to find its inverse discrete Fourier transform. So as you know that the value of xn here, its value is 1 upon n. The summation k is equal to 0. Here it will be n minus 1 and this will be capital Xk here and this will be omega to the power minus nk. Clear? We have to find the inverse discrete Fourier transform of this. So we get its answer. We know the value of capital N here is given as 4. This will be xn is equal to 1 upon 4 here. And we will do summation. K is equal to 0 to 3 and xk. And the value of omega that I just mentioned, what it will be? It will be iota. So we will substitute it. We will get iota to the power minus nk. Now what is given here, students? It is given x0 and x1, x2 and x3. These are the terms given, right? You can see it is x0, x1, x2, x3. It is given in capital. Now we need to find it in small letters, that is small x1, x2, x3, which are 1, 2, 3, 4, as we did it before. So what I will do here, I will put 0 in place of n, right? From here we will get x0 is equal to 1 by 4 summation k is equal to 0 to 3. Now what will come here? This will be xk. In place of n, I will put 0. So iota to the power of 0 is 1. So this will be equals to 1 by 4. If I will put its value, then this will be x0, x1. x2 and x3 will be there. If we put the value of this 1 by 4, right? So what will we get here? We will get 10 minus 2 minus 2 iota. Minus 2 and plus 2 iota will be its value here. What is happening here? 2 iota and 2 iota is getting cancelled, right? If we subtract 2 and 2 and 1 more 2 from 10, then it will be 4. So we get the value as 4 divided by 4. What it will become? It will be 1. Similarly, we have this here. We will discuss x1. So what should we put value of n? We will have to put it 1, x1 is equal to 1 by 4. Summation k is equal to 0 to 3. This will be kx. Here, this is xk and this will be iota raised to the power. Since we will put 1 in place of n, so it will be iota to the power minus k. Clear? Now we will take 1 upon 4 out. We will replace k with 0. So we get x0, which is iota to the power 0, that is 1. This will be x1 and iota to the power minus 1. Plus this will be x2 iota to the power minus 2. Plus this will be x3 iota to the power minus 3, right? We will put the value 1 upon 4. The value of x0, what is the value of x0? It is 10 and the value of x1 is minus 2 iota and here it is iota inverse. So I can write it as 1 upon iota. Clear? Plus here x2, the value of x2 is minus 2 and this will be iota square in the denominator. And then here the value of x3 that we are getting will be minus 2 plus 2 iota and we will take this iota cube to the denominator. Clear? Iota square is minus 1 and iota cube is minus iota. We will simplify this. And it will be easy, but whenever this type of question is given, so we'll simplify this in a more detailed way, it will be minus 2. Minus 2 iota and we will multiply iota with both numerator and denominator. So students, we will get iota square here which is minus 1. It will be minus 1 and this will be iota, right? This is iota square, its value is minus 1. This will be plus 2, we will multiply by iota both above and below and get iota power 4 which is 1 and iota above. This will be minus 2 plus 2 iota and this will be iota in the numerator. Clear? This is 1 by 4. And now from here we will get 10. This is negative, so this will become positive. We will get plus 2 iota here also. We will multiply by this iota. So this will be iota and iota square. plus this will be 2 and this will be minus 2 iota, clear. Plus this is 2 iota square, so we are getting this value. But look here, this 2 iota and this 2 iota getting cancelled, right? I'll simplify the value of iota square a bit. So this is 1 upon 4. And here it will be 10 and we have this iota square's value as minus 2. Plus 2 and this will be minus 2. They will cancel out 10 minus 2. It will be 8 and upon dividing by 4. What will we get as its value here? This will be 2. In this way, we can calculate the inverse discrete Fourier transform. Now we will put the value of n as 2 here. Clear? In that case, what will we get? We will get x2, right? So here it will be 1 by 4. And then the summation will be, here it will be k is equal to 0 to 3 and this will be xk. And because we have iota raised to the power n here, we are replacing n with 2. So it will be minus 2k. Is it clear? We can write it like this, right? Okay. Now look here what we will do. We will again put the value. On putting the value, it will be 1 by 4. Put k as 0. So this will be x0. Then if we put 1, then from here we will get the value as x1. And iota to the power minus 2. I can write it as 1 upon iota square. Then next we will get x2 and this will be iota to the power minus 4 here. I can write here iota to the power 4, right? Then this will be x3 and iota to the power 6. Is it clear? Put the value of all of these. 1 by 4 here. And what is x0 is given as? It is 10. Value of iota square is minus 1. And we will multiply minus with this. So we will get 2 plus 2 iota here. Value of iota to the power 4 is 1. So x2 will remain the same and its value is minus 2. Now we have iota to the power 6. Iota to the power 4 into iota square is minus 1. So multiply minus 1 with this. So students, this will be plus 2 and here minus 2 iota, right? On simplifying, you'll see some terms will cancel out. 2 iota with 2 iota. 2 cancels with 2. And 12 by 4 will be 3. So we will get the value as 3 here. We can solve it like this here. Now we will discuss about x3. How we will find x3? I'll write with red color here to highlight what you have to do. So when we are talking about x3, what we will put in place of n? I will put 3 in place of n. What we will get as its value here? Its value will be capital X3 is equal to 1 upon 4. This will be summation. K is equal to 0 to 3 and we will get here xk. And here the power of iota will be, what will we get here? Since we are replacing n with 3, its value will be minus 3k. This is the value we will get. Now we will expand this, right? So this will become 1 upon 4. Now we will take this and put it here. So this will be x0. Then we will put x1. So this will be iota cube in denominator. Then we will put x2. We will get iota to the power 6, right? And when I will put x3, we will get iota to the power 9. Clear? We will get this now. Pay attention here. What will we do next? We will put their value. So we will get the 1 by 4 as it is here. And this x0, its value is given as 10, right? And now iota cube. Here we will multiply by iota above and below. So the denominator will become iota power 4, which is 1. And the numerator will be multiplied by iota here. On multiplying, we will get minus 2 iota. And this will be iota square. It is minus 1, so it will become plus 2 iota, right? I am sorry. Therefore, it will become plus 2. The value of iota power 6 is minus 1 as iota power 4 into iota square. So it will be minus 1 and x2 will remain here. Multiplying this by minus 1 will give us plus 2. I had explained we can write iota power 9 as iota power 4 into iota power 4 and iota. It is 1, its value is also 1. So we have only iota left, right? I will multiply iota in numerator and denominator. So minus 1 is below. And will multiply iota in the numerator, clear? So here in the denominator it will be minus 1, then minus will be multiplied by this. It will be plus 2 iota. And if from here we will get this as the value of minus iota square here, then we will get plus 2 iota. Now let's simplify this. Some terms are cancelling out. 2 iota is cancelled out with 2. So we get this as 16 by 4, right? 16 upon 4. Now what will be its value on calculating? It will be 4. It is easy. What will be the sequence that we get here? The inverse discrete Fourier transform that we will get here. The sequence we are getting is 1, 2, 3 and 4. So this is how we calculate it. And I had explained you in previous question as well, that its discrete Fourier transform is this. So the inverse of this can be calculated like this here. Is it clear? Now, if you are preparing for the CSIR NET IIT-JAM, our books are available on Amazon and even on Flipkart, and you can buy them from there. We will move to another question. We are asked to find the inverse discrete Fourier transform. Now, what is capital N given here as? It's given as 3 and we have to find the inverse. This means what do we have to find here, students? We have to find xn. and to find the xn we will get 1 upon n here. Summation k is equal to 0 to n minus 1 xk omega to the power, here it is minus nk. This is what we will get. And this omega, what is its value? E power 2 pi I. Upon it is capital N, that means it will become 3. Clear? Note that capital N comes in denominator and in place of n we put 3. And we know that we get this value as cube root of unity, where the value of omega cube is 1, right? And we get 1 plus omega square. If you remember, its value is 0, we will use this value here. Clear? Now let's discuss this. First of all, here we need to calculate, since we have x0 and x1 and x2 are given. This is what we have. This is x1, it is x2 and x0. We need to find the corresponding small x0, small x1 and small x2. What should we do? First, we will put the values. So it will be xn is equal to 1 upon 3. And here from summation k is equal to 0 to, this will be 2 and this will be capital xk, and omega will remain here. So we will solve omega later. It will be minus nk. Is it clear? Now what do we do? First, we will put 0 in place of n. When we will put 0 in place of n, what we will get? We will get here x0 is equal to 1 upon 3, right? And then here this will be summation k is equal to 0 to 2. It will be xk, and we will put 0 in place of n, so omega raised to the power 0 will be 1, right? Now we will expand this. So we will get the value from here. We will put 0 in place of k. Here it will be 1 by 3 x0, x1 and x2. We will put these values of x0, x1 and x2 here. So we will get 1 upon 3 here, and value of x0 is 0. And here it will be plus 1 minus omega square plus 1 minus omega. Clear? So this is what we are getting here as its value. Is it clear? And when we will simplify this, it will be 1 upon 3. Then it will be 2. And let's take minus common here. It will be omega plus omega square. And we know the value of omega plus omega square is minus 1. I will put that value here. So 1 by 3, this will become 2 minus 1. This will become 3 upon 3. So what will we get as its value from here? We will get 1. Now what we will do? We will put 1 in place of n, right? So what will I do here? We will get this as x1 equals 1 by 3. Here summation k is equal to 0 to 2. And then this will be xk. Wherever it is n, substitute 1. So here it will be omega raised to the power minus k. Clear? Now we will simplify this, right? This will be 1 by 3 here. And when I will open this up, it will be x0 and omega to the power 0 will be 1, right students? Then this will be x1 and omega to the power minus 1. Then x2, omega to the power minus 2. Clear? Now, as we know, value of omega cube is equal to 1. If I will divide it by omega once, then it will be omega square is equal to omega to the power minus 1. If I divide this by omega square, then this will be omega is equal to omega power minus 2. We can find out these two values here with this equation. Pay attention to the values we got on dividing with omega and omega square here. We are going to use this here, and now what are we going to do? Its value will be 1 by 3 from here, x0, and value of omega power minus 1 is omega square. So this will be plus x1 omega square here, plus x2 and omega to the power minus 2 is omega. This is what we will get here, 1 by 3. Now we will put its value. The value of x0 is 0. The value of x1 is 1 minus. It will be omega square into 2 omega square, right? Plus the value of x2. Here is 1 minus omega into omega. Here we will get the value, right? It will be omega. Is it clear? We will simplify this. It will be 1 upon 3 and it will be omega square omega to the power 4, and we will take this inside. And then it will be plus omega and minus omega square. You can see here this omega square will cancel out with this omega square. Now the value of omega to the power 4. Omega cube is 1. So the value of omega power 4 will be omega. So on solving, what will we get the value here? It will be minus omega. So 1 by 3, from here it will be minus omega and plus omega. And then we will get 0 after cancelling out. x1 will be 0. Now we will find the value of x3. And what we will put as n here? It will be 2. Then here we will get the value as x3 is equal to 1 by 3 summation. K is equal to 0. Here it will be 2. And wherever it is given n, what we will put there? We will substitute 2 there. It will be xk omega to the power minus 2, right? What will come here? Pay attention. It will be k. Clear? Now we will put the value 1 upon 3, right? If we will put the value once. So we will get x0. Then it will be x1 here and omega to the power minus 2. It will be x2 omega to the power minus 4. Is it clear? Now look here, I'm going to calculate its value. 1 upon 3, this will be x0 plus x1. The value of omega to the power minus 2 is omega. Now this omega to the power minus 4, I can write it as twice of omega to the power minus 2. Now its value is omega. Omega into omega is equal to omega square, right? You need to understand this clearly. So this will be x2 omega here, right students? Now put the value. 1 by 3, we are getting x0 as 0. The value of x1 we are getting is 1 minus omega square. Here we are getting this and omega will multiply with this term. Plus value of x2 will be 1 minus omega into omega square. Is it clear? We will simplify this. It will be 1 upon 3. This will be omega minus omega cube, right students, and plus 1. Multiply it with omega square. So omega square. Minus here we will get omega cube. The value of omega cube is 1, right? So we will substitute 1. It will be 1 by 3, right? And substitute omega cube as 1. Here it is omega plus omega square. And the value here of omega cube is 1, right? So this will be minus 1 and minus 1 here. Now what is the value of omega plus omega square? It is minus 1, right? We will put this minus 1 here. 1 by 3. Minus 1 will come thrice. On adding we will get minus 3. So minus 3 upon 3 will be minus 1. Clear? That means the sequence given here, capital XK, right? What it was? It was given 0. 1 minus omega square and 1 minus omega. So the inverse discrete Fourier transform of this sequence xn. What did we get that here? First we got 1, second value we got 0, and third we got minus 1. Right students? What are these values here? These values are the inverse discrete Fourier transform. We can solve it this way. We are being asked to find the discrete Fourier transform in next question. I explained to you that 0, 1 minus omega square and 1 minus omega's inverse discrete Fourier transform was this. If I take the discrete Fourier transform of this, then that should come, right? Let's solve it. As I have explained 2 questions, so it must be clear. Now here the value of capital XK will be summation. N is equal to 0 to n minus 1. So students, here this will be xn, clear? And it will be omega to the power nk, right? And since value of capital N here is 3, so what will we get as omega here? The value of omega is e to the power 2 pi, meaning it will be 2 pi I upon capital N, that will be equal to 3, right? And what do we have here? We have this as cube root of unity, clear? So we know the value of omega cube is 1. Here and 1 plus omega square's value is 0, because this is the property of cube root of unity. Now let's discuss students. Look at these values here. What is this given here? Like this 1 here, it is given as x0, right? This is x1 and this is x2. Now we have to find capital X0, capital X1 and capital X2. Now what we will do? When we will solve it, the first thing we will do is put the value of n. Capital Xk is equal to the summation from n equal to 0 to. Capital N is 3, so this will be 2, and here it will be xn and omega power nk. Now wherever it is k, we will put 0, right? So this will be x0 is equal to summation n is equal to 0 to 2, and here this will be xn. We will put n as 0. So the value of omega to the power 0 will be 1. Now expand this. We will get the value of this as x0 here, x1 and x2. We will add these 3 terms. We will get 1 plus 0 minus 1. What will be its value here? It will be 0. Now let's talk about this capital X1 here. So the capital X1, we will put value of k as 1, right? Here it will be n is equals to 0 to 2, small xn, and since k is 1, so omega to the power, it will be n. Now we will expand this and the value we will get here will be x0, and here it will be x1 omega plus x2 omega square. Is it clear? So what is the value of x0 given here? It is given 1, right? And value of x1 is 0, right? The value of x2 is minus 1. So this will become 1 minus omega square here. Is it clear? In the same way, now we will calculate the value of x2, right? So for x2 here, what should we put as k? We should put 2. x2 is equal to, here we will write n is equal to from 0 to 2. And this will be small xn. And because we are putting 2 in place of k here, so it will become omega to the power 2n, right? Now we will solve this. So we will get small x0 plus x1 omega square, plus it will be x2 omega to the power 4. Clear? Now we will put the value of x0. The value of x0 is given 1 and x1 is 0. And x2 is minus 1. So it will be minus 1 omega to the power 4. We know omega cube is 1. So omega to the power 4 will be omega. And we will multiply with omega. From here, we get the value of this as 1 minus omega, right? And I have already explained to you that the small xn is given 1, 0, minus 1. And what is the discrete Fourier transform which we calculated? The discrete Fourier transform is 0. And here it is 1 minus omega square, and it is 1 minus omega, right? So this is how we do this here. I hope you have understood the whole concept, right? This is one question. For comment box, how much time did it take you to solve this? Please comment and let me know. And you can watch entire playlist of the Fourier Transform series from here. If you are preparing for CSIR, NET, GATE or IIT-JAM and want to improve your general aptitude, then you can watch these videos from here. Please subscribe to this channel. Thank you very much, students.